Thank you. My microphone. Oh, good people here. Good. Okay, can you hear me okay? Citizen, can you hear me okay?
Yes, I can
Okay.
hear you.
Okay, so it's time. So let's get started. I'm Tomo. Welcome to the class. Who is taking this as a class? A lot of people are taking. Are you guys taking? Or no? Oh, okay, good. You're welcome. So this is a class to read new journal papers. They help each other. So no need to. Welcome. Good morning. Yeah, no pressure here. We just read papers together. That's about this class. Okay, let's. I want to introduce so today's introduction. So I want to introduce the class to you. So it's me. I'm Tomo, and I'm doing this kind of research. Maybe I touch upon during the class today. So I'm doing a cosmic star measure history using JWST, and there's some students of mine are looking for Planet 9 and the solar system planet. And then also Tetsuya-san and me and then others are building a new radio telescope in Taiwan dedicated to detect fast radio bursts. So these are my main research area. Okay, so that's just myself. And then let's introduce this class. Do you know who is this lady? Taiwanese, who is this lady? Yes, city mayor of Hsinchu, right? I don't know why, but the Hsinchu city mayor always have a problem. So this is her, I think this is her PhD thesis, right? And then this is someone else's paper. Do you see it similar? So please be careful. You cannot copy and paste someone's figure in your thesis. So please be careful. And then it's not just this city. Do you know who is this? Do you know who is this guy? Dora, do you know? You don't know? Oh, because you are not Shinchuren, right? You guys know? Yes. Previous Shinchu city mayor, right? And then, there was a problem. What is okay, another, his thesis was a copy, right? So that's why, he couldn't run for Taoyuan city mayor. So it was a problem. So if you want to be a city mayor in the future, please don't copy and paste someone else's paper. It was a pity, this is, he was a very nice to me, because I was joining a quiz competition in here. And then it was very difficult because quiz was in Chinese. So I have no idea what they're talking about. And then I kept losing, but then city mayor was helping me all the time. So it was very nice, but then, he's not a city mayor anymore. So someone else's result, right? And then to do that, you need to read new papers. You need to know what is published and what is not to be unique, right? Not just copy and paste, but then if you produce a similar results already published, that's not good, right? If you spend a lot of time write a paper and it's already published, that's not good, right? So you need to know what's happening in new papers. Then I have a question. Do you know how many new papers appeared on arXiv in astronomy field this morning? Okay, maybe I should ask another question. Who checked Astroph this morning? Oh, good. Okay, some people took this class last semester, right? So maybe they have a habit. So good, they raised their hand. So that is actually a goal today, one of the goals of this class. So I want you guys have a habit to check Astroph every morning, just like you check, Facebook or Instagram. You check Facebook, Instagram, Astroph. That's my goal in this class. Okay. Okay. So this is the answer. Well, actually, this is yesterday. But yesterday itself, Monday, there are 48 new papers. And in astronomy field only. And it's impossible to read 48 papers by one person, right? If you need to read 48 papers every day, that's impossible, right? So that's the purpose of this class. So we help each other. We take turn to read these new papers and introduce it to other people. So we help each other to keep up with new papers. So that's the purpose of this paper. Not this class. Then so it's in Chinese. It's Mai Song Xi. It's not Mai Song Yi. If you read one paper, your friend is going to tell you about 10 papers. So that's the spirit of this class. Okay. In English, it's a buy one get one, right? But then in this class, buy one get 10. So that's good, right? Okay, so that's the purpose of this class. And actually, in overseas, this is very common. Every top universities have this. This is what? This is. Is it okay to close this window? I'm a little bit worried. Okay, it's okay. So this is a Princeton University, and it has a big astronomy department. And in the under, they have a Peyton Hall. It's an astronomy building called Peyton Hall. They have this meeting, Astro Coffee, every morning at 10:30. So a lot of professors and postdocs, students get together, talk about new papers. This is very nice. As soon as important paper comes out, all professors come here and explain to students what's important, what's the problem. So it's very nice. You just go there, drink coffee, and you already know about new papers. It's very nice. And also, this is Ohio State University. Ohio State University has also a very big astronomy department. They have this Astro Coffee every day. And then this is amazing. Ohio State University. At some point, there are 80 people joining this. It's like huge class because it's so useful. I mean, discussion there are very top level. So, yeah, Goethe University in Germany, it has an Astropage website, and also, yeah, so, well, yeah, when I was, before I was at the University of Hawaii had this too. Before that, I was at Niels Bohr Institute in Denmark. We had this Astro Coffee. So most of the top universities have it. So, the top university, one of the top university of the world, right? NTHU should have one, right? Does it make sense? Do you agree? Well, the top university, no? Okay. And NCHU too. Yeah. And then, okay. So goal is, I already read it, but you check line, FBIG, and Astropage. I want you to check it, new paper every day. Okay. But then it should be easy. If it's very difficult, if it takes say 2 hours to check new papers, then you cannot do it every day, right? Say, okay, how many minutes takes if you check live Facebook IG this morning, your own, right? How many minutes does it take to check new message? 2 minutes? Okay, yeah, okay. If it's 2 minutes, easy, right? You can do it every day, right? Or several times. So it should be as easy as this. Maybe not 2 minutes, maybe something like 5-10 minutes, like reading a newspaper. So it should be easy. Otherwise, so the important thing is to continue. If it's too difficult, we cannot continue. So, then, okay, where am I going? Then I show you an example later. Okay, but then first, we have a Facebook here, Facebook group of AstroPH. If you haven't joined, please join here in this Facebook group. Here, we're going to share the papers we share here. Okay, I'm going to read this paper tomorrow and I share it. Okay. Then I'll send you the link later. Okay, then the problem is this original website here is a little bit, just monotone. There's no figure and it's just abstract. Then it's submitted order. So it's a little, this is not so sexy to use it. So nowadays, there are a lot of covers. And then one of them is this Penty fields that I use. So here, the list is the same. But then there's an AI behind this. And then as you keep using it, AI is going to learn your habit. And then they reorder the list to your taste. So AI is going to list up papers that I like on top. So actually, I don't need to check 48 all the papers, but if I check maybe top 20 or 30, then most of the papers that I am interested in are covered. And also there are options. You can show abstract, or I like this option, show figures. So because the original archive site, they don't show figures, so it's good to show here. By the way, this archive server is a preprint server. So when people's paper, it's usually when accepted, the journal site, it takes time to put your paper to appear on the journal site. So people first submit it to archive server so that other people can read it immediately. So that's where the latest results going to come. So a lot of people will just check archive server for new papers. They don't check the journal website because it takes time for the paper to appear on the journals, because journals, they need corrections for English and figures, and right, so it takes time. But here it's quick. Yes, okay. And then this is how the class work for those taking the class. So please check Astroph every day. So tomorrow I'm going to ask you who checked Astroph this morning. So I hope everyone can raise their hand. So tomorrow morning, please check one of those sites, okay? And see if there's an interesting paper. Okay. Then, okay, here you can vote. So, okay, I like this paper, you can vote. Then there's also a group for NTHU Astroph. So it's in that group, if you vote, your paper recommendation is gonna come up. Okay, that way other people know, you like that paper. And then, okay, later I explain, but I want you to separate into 3 groups: Tuesday groups, Wednesday groups, and then Thursday group. And then I want you to take turn in that group to present a very short summary, 10-minute summary, which I'll show you the example later. How many people? There are a lot of people. Okay. Anyway, and then for those taking it class as a grade, grading is very easy. If a 6 presentations, that's very simple. So 8 presentations, we have a 16 weeks semester, right? So basically, every week we make your exam. So I recommend you make more presentations earlier in the semester, so that you are not too busy at the end of the semester. Okay, this is also important. So every 2 weeks your turn comes, right? And then say for some emergency, or you get sick, or you need to go to hospital, and you need to skip the class when you are assigned presentation, then please find the replacement yourself. Hopefully within the team, you can find it so that someone else can do it for you. Okay, if you don't do it, I need to put you -1, so please be careful, okay? And also, please don't be late, especially on your presentation day, okay? Okay, and then this is some extra in this semester, but this class, thanks to Terry and Darian, previous TS, they applied for the extra funding, and then we got the funding from the EMI. So we need to do something about the English. So their plan, don't complain to me if you don't like this plan. This is their plan. They submit the proposal. They submit a proposal to pick a difficult word in the paper and explain to it in a very short 5 minutes format. And then please add a short report below. I think this is for only students taking the classes, unless you want to do it, okay? So for example, you read a paper, and then the paper comes with the word, say, AGN. And then it was difficult for you, then please try to explain this to you, to others. Okay, AGN is blah, 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 blah. When you read a paper, you come up with a dispersion measure. What is a dispersion measure? Then please try to explain. So that's how to do it. And because of this, we have funding to invite 1 guest speaker. So during the semester, maybe we can invite 1 guest speaker. By the way, I forgot to introduce, but Hare is a TA of the class. So she's in charge of doing a camera and a recording. Okay. Thank you for your help. Okay. Then, yeah, the format I propose is, so I want 3 papers every day, within the 50 minutes class, right? So please summarize one paper in 10 minutes, and please don't go to details, and don't explain all figures. Just one important figure is fine. Okay. Then, as I was saying, I do not recommend spending more than 2 hours to read a paper. You don't need to read everything in the paper. Just try to read the most important part. Okay, because so that if you spend 10 hours to make a detailed report, that's good, but you cannot do that every day, right? So you need to keep it simple and short so that you can continue this activity. Okay, I'll show you an example. I just now show you an example by reading actual paper. But before going that, is there any question so far? Okay. Okay, so I should have explained this too. So some tips in summarizing a paper. What is the goal of this research? Why are they doing this? And then what is new and original in this paper? And how does this compare with previous work? So these are 3 more important points. So in other words, you just need to answer these. You don't need to explain the details of the method or analysis, things like that. Typical example of a student. Oh, okay, this happened in the past. Oh, here's a paper. Oh, figure 1 is this, figure 2 is this, figure 3 is this, and then all of them, and then they run out of time. This is very typical, but then please don't do that. Okay. Yeah. Okay. Right. Oh, so there are some good examples. So discussion is another purpose of this class. So this paper in the past was taken in this class, had a very good discussion about Dyson sphere. So we are reading a paper about Dyson sphere, and then we are discussing, and we came up idea. Oh, what about Dyson sphere around the black hole? And then, oh, that's an interesting idea. And he wrote a paper about Dyson sphere around the black hole, and he published it, and he got some prize. So that was a good outcome. And also, this guy was we were reading a paper. He was a very young student here, young researcher here. I don't know where he's now, but he was joining this Astroph discussion, and then we're talking about this. What I forgot that this. I forgot what I was talking about, but I think we're talking about the correlation between the duration of the first radio burst and the luminosity of the first radio burst, or energy of the radio burst. And then we are discussing, and we came up with the idea, maybe we can use this for cosmology to measure the distance. And then, okay, then he wrote a paper, and then it was featured in a magazine. So that's another successful example. And then this is a more recent one. So we are reading this Chimes fast radio burst catalog paper. And then catalog was showing the number increase as a function of observational time. So as the telescope observes more, the number of the bursts they detect increase, right? As telescope operates more, the number increases. And then we noticed that, but this telescope is not considering the bias of the observation. And then we came up with the idea that, okay, maybe we should correct for this bias. And then this Shotaro-san came at NTHU, correct for this bias. And then later it was a press release. He was on the newspaper. That's another successful discussion. So I hope, in this semester also we have a useful discussion. Okay. This is not working. Okay. Then any question? If not, I want to show you an example. Let me switch the window. Okay. Okay. So this is a paper I picked today. This okay. Investigating the law of mergers in galaxy assembly in the other universe. I thought I was checking this archive, and then I think this appeared yesterday or something. And then I thought it was interesting. Tracing galaxy mergers as a function of redshift from the galaxy. And um, please pay attention how I not reading the paper. Okay, so the part I read is marked by green, right, or blue, right? So the other part I didn't read. So I'm not reading the whole paper. This is the microphone. Okay. So using the JWST data, they started the history of merging. Okay. So here. Okay. So merger fraction. So among all the galaxies, how many galaxies are merging? So this is merging history of the universe. This is something interesting to understand the galaxy evolution. So here's a redshift, right? And the merger fraction. How does it evolve? Is there more mergers in the past? More mergers in the later? Oh, you're taking a picture of me? Yes, but I think you're supposed to take a picture of students, not me. But anyway, fine. So then, how do we select it? So they're using the JWC samples, using Cosmos, UDS, goods and goods nodes, and EGS and the Abel cluster. So they're using many JWST field to correct 1,200 mergers. How they select mergers? It's in here. Here. So they use asymmetry index x-axis, and then this is Gini coefficient. The galaxy, no regular galaxies are here, and the mergers has a larger asymmetry. And then Gini coefficient, this is statistical coefficient, but see how galaxies uneven. That's measurement. So they use these index to select the mergers. Okay, and then they plot the fraction as a function of redshift. So here, let's look at the A. Can we look at the A? Okay. So this is merger fraction as a function of redshift, and their data points are black. It seems, does it look so flat? It seems flat, right? But this is misleading because merger time scales are different at different redshift. So you need to correct for this. Studies here. So this is a merger time scale as a function of redshift. And the merger time scales are shorter in high redshift. This is because in high redshift universe, mergers happen more quickly. So, there are two galaxies, right? And then they merge, right? This process is faster in the earlier universe, and it takes more time in a nearby universe because the density of the universe is higher here. So the collapsing time scale is higher too. With the expansion of the universe, the density of the universe is lower here. So the collapsing of two things, it takes more time. And this needs to be, the Earth is merging with other planets. Okay, so this needs to be corrected for the collapse because here, you need you can see the merger for longer time scale, right? So because it takes more time, so you observe it for longer. Say here, maybe you can see the merging process go unevenly. But maybe here, you just need to, you can just see 500 million years. So you need to correct for this time scale difference. Okay, so even if you have the same number here, because it finishes quickly, it looks like a small number. Here, it takes long time, so you have a lot of chance to see. Okay, so after you correct for this, then it becomes this. Where is it? Where is it? Here. Okay. So now, after you correct these things, these black points after the correction, and as you can see, it's increasing towards higher redshift. So in earlier universe, you have more mergers. Okay. What's your name there? Debbie, what's the name of your friend? You gray shirt. Ian. Ian. Do you know which redshift is older in the universe? Okay, redshift 1, redshift 7, which universe is older? Okay, redshift 0 is now. This is older in the universe. Okay, I come to you next question. Okay, so please pay attention. Okay, so okay, Ian, is the merger more mergers in the past or less mergers in the past? Okay, compare this and this, which is larger? Red or blue? Red or black? Yes, black, right? So, and how much more? How many times more? Yes. So by order, right? More than a factor. So that's the conclusion. And the another conclusion is that star formation rate. Okay. Another important outcome is here. Here. So this is something already known, but then here, this is showing the main sequence or so-called main sequence. So stellar mass times star formation rate. And then these blue one is a regular galaxies with no mergers. And then red one is a mergers, which has higher star formation rate. Dora, which one has higher star formation rate? Merger or non-mergers? Red or merger? Yes. So merger, how much more? Can you tell? Yeah, okay, it's difficult, but 1.7 times in the paper. It's maybe. Well, this is known, but it's again, it's confirming that merger is increased. So these two are the main conclusion of this paper. And what's unique about this is the first time to go merger study to go such a high redshift here. Here, as you can see, this is the power of JWST. So previous work, as you know, if you notice here, right? These are previous work, right? Because of the JWST, the work is going here, redshift 5, 6, 7, 8 for the first time. This is a huge jump here and here, no? This is a ground-based telescope or Hubble Space Telescope, and this is 6.5 meter space telescope. That's the power of the 6.5 meter space telescope. So that's a summary of the paper. I hope I finished in 10 minutes. Probably, right? Something like 10 minutes, right? Okay. Any question? Okay. Because there's a gap in the telescope, no? Because of I think it's because of the field. Because JWC field is small, so the sample size is probably, yeah. Yes, please.
The black line is the best of more data or just database?
I forgot. What does it say? The best fit to all of the data. So all the data. Yeah. Okay. Any question online, please? Sorry, Vignesh, are you speaking?
Yes, professor. I have a very naive question. So, according to figure 10, the merger rate is increasing as a function of redshift. So, could you say how could this affect the AGN evolution? Because mergers can trigger more AGN activity, right? So,
Yeah,
that
that's a good point.
basically we should expect more number of agents at high redshift, right? If I understood this correctly.
That's an interesting prediction. So please check it with the data. You can check it data and you can write a paper. It'll be interesting to compare the AGN fraction increase with this, I think.
Sure, professor. That is what I wanted to ask you.
Very good point. Very good point. Any other questions? Okay, another thing is this class is, there's no stupid question. So we try to help each other to understand. So anything you don't understand, please don't hesitate to ask a question so that, we help each other to understand. Yes, one more question.
Black does this mergers eventually goes to a black hole at the end point, or
Probably, yeah.
so we can find the rate of the increasing the mass of black hole based on this data, I think.
Yeah, that's a very good point. Yeah, so these are galaxy mergers, and then major mergers. I forgot which one is. There's some major merger points. Major mergers usually end up with one giant elliptical galaxy. So two galaxies merge together to make another galaxy, and usually at the center there's a supermassive black hole. So that's closely related. Another good point. Yes, Teja-san, please go ahead.
Thank you, Tomo-san. I don't know if we already discussed this or not, but then, so there are multiple colors in this figure. And then
Yes.
if I look at the same color data,
Yep.
actually it go up and then go down actually.
You mean the red one?
Red
These?
one, and then yellow, and then black, cyan, all of them actually show this kind of turnaround. I wonder why this happens.
Sorry, I didn't read it. I don't know. I didn't read that part.
I see. Yeah, because it seems that the fitting curve is using this raging part. But then
Yes.
many data points actually going down. So therefore,
right.
I wonder if there may be incomplete observation, maybe.
Maybe. I need to read that part of the discussion.
I see. Thank you.
I think it's because of the star formation rate at redshift 3. I have read some paper about this before. I think it's because of those galaxies have a higher star formation rate, and then the main galaxies are going to have this feature. I can share the main paper with the group.
That'll be great.
I know.
Please post it in Facebook.
Yes, sure.
Yeah. Okay. So just one more thing. Please pay attention to that, how I'm not reading the paper. So I go through the paper again, and I read the abstract, right? But I'm not reading these, right? There's no sign, right? I look at see, this is a long paper, but I'm skipping a lot. Then, okay, this time scale, I read it because that's important. And then I'm not reading. I look at the main figure here, corrected star formation rate here. And then I read this about the figure. And I'm skipping, and then I look at the main result. I read the main result and then conclusion. So I'm skipping a lot of papers, right? I'm not reading all the details, right? So that's what I wanted to do. I don't want you to read the whole paper. I just want to try to find the important, try to find the essence of the paper. Okay, and then now we have 10 minutes left, and I wanted you guys to separate into 3 teams. Tuesday team and Wednesday team and then Thursday team. Where was it? So here's a sign up sheet. So I wanted you guys to sign up here. Here. Tuesday team and then Wednesday team and Thursday team. Maybe okay. If you have access to the Facebook, I already posted this link. If you don't have the link, maybe can you after the class can you come to Bahare and then sign up? I like Tuesday, I like Wednesday, or I like Thursday. Okay, and then I want to decide who is going to present tomorrow. Oh, Terry volunteer. I see Terry. Okay. Anyway, is there anyone who can read the paper tomorrow? Okay, Priyanka, can you take a note? So Priyanka and Terry can show example. Is there anyone else? Angel too? Oh, good. Some motivated people. I think this is good because Terry and Angel took this class last semester too, so they sort of know how it works. For this student, I think they show very good examples, right? I hope. Okay, so that's all I wanted to cover today. Any questions today? I think NTHU people can find the link to the sign up sheet on the Facebook. So please sign yourself up for your preferred day. Any other question? Per your presentation. Yes. Yes, pretty. You mean my PowerPoint slide? Oh, okay. I'll put it somewhere. I haven't done it yet, but I'll do it. Yes. I forgot to say, but then for undergrad students or students not in astronomy department, you can also present news. Maybe it's difficult for you guys to read the whole paper. In this case, you can select some news. So, for example, let me share the screen again. Something like this. One example is this. One example is here. So, for example, if scientific, so here, if you go, there are a lot of new astronomy news here. And I think these are easier to read than the whole paper. So you can summarize this news article. That's very easy to do. That's also possible. Yeah, and also if you don't, if you have a problem finding a paper or news to read, just let me know. I'm happy to suggest you some articles. Okay. I think as you join this, as the class goes on, probably you have better idea what's going on. Okay. Any other questions? Okay. If not, please try to sign up your favorite day by tomorrow. So we just finalize the group tomorrow. If you don't know the link to the sign up sheet, please come to the hurry now for sign up. Okay. Any final comments or questions?
How can we join the Facebook?
I should send you the link, right? I will.
I think I apply for it.
Okay. Then I should just click approve, right? I will send the link later. Are these yours? No, this is not you. This is 11 years ago. Okay. Okay, so let's close the class today. And then tomorrow, Terry and Joe Priyanka will show more. So see you tomorrow. And then please come here to sign up. See you and NTHU people tomorrow.
Thank you. See you. Bye bye.
Okay, bye-bye.
Bye bye.